Dear students, a very good day. Today we are going to discuss about instruction format, data transfer and manipulation, bus architecture. The contents are as follow: operational flow, instruction format, bus architecture, operation of a bus. Operation flow. Operation flow tells us what are the different steps that are taking place inside a processor when an instruction is given. Okay, this diagram the diagram here shows start, fetch next instruction, execute instruction, and halt. There's an execute cycle and there's a fetch cycle. So what exactly happens when an instruction is given? So following steps are followed. This step 1, that is processor fetches the instruction from the memory. All the instructions are normally stored in the memory, and the memory address of an instruction is stored in program counter. Program counter is a special register for this purpose. Whenever an instruction is to be fetched, program counter points to the address of the memory location where the instruction is stored. So processor asks the program counter where the instruction is stored and fetches it from the memory, or you mean it can take the instruction from the memory. Okay, step 2, program counter holds the address of the next instruction. After each instruction, its value is incremented. This means program counter is holding the particular instruction address. As soon as processor takes its instruction, program counter value is increased by 1, so that now it can point towards the next instruction. Thereafter, the instruction that was taken from the memory is loaded into the register, that is instruction register, that is present in the processor. Now, depending upon what the instruction is, processor performs the operation. Suppose it is an addition instruction, the processor will perform addition operation. If it is subtraction operation, processor will perform subtraction operation. In the similar way, if we want to move data from one location to other, then that is a different type of instruction. Normally there are 4 types of instructions as are shown here that can be performed. Okay, processor and memory. This means data transfer is taking place from either processor to memory or memory to processor. This means we can take data from memory and put it in any register of the processor, or at the same time we can take data from processor and store it in the memory for future use. Processor input output. This means that data is transferred between input output and the processor. Like right now we are watching this presentation, so from the processor to the output this data is being transferred. Then data processing. These are the instructions such as arithmetic and logical, that is addition, subtraction, logical AND operation, etc. Then there are certain control instructions. Control instruction changes the flow of memory, flow in which the program is moving. Like we all have seen that in C programming or C++ programming, there is instructions such as loops. So it is continuously following a particular loop and a set of instruction is repeated. But once a condition is fulfilled for the loop, we get out of the loop and next instruction is followed. So control instruction works almost in a similar manner. Next is instruction format. Instruction format is related to what is the format of an instruction when it is stored in memory or in processor. Depending upon which microprocessor we are using, the instruction format changes. But in general, it has the following format. There will be an OP code. This is also known as operation code. Okay, and there will be a space for data or address. I have taken here the example of 8085 microprocessor. In this, normally OP code is 1 byte and data or address can be of 1 byte or 2 byte. So particularly this whole instruction format will be of 3 bytes maximum. Okay, but for other microprocessors, suppose like 8086, it can be 5 byte as well. Now for 8085 microprocessor, there are 3 types of instruction: 1 byte instruction, 2 byte instruction and 3 byte instructions. Okay, now we will see all of these different types of instructions one by one. Here I have shown the memory location. Okay, memory location that I am using is 2218 and data is stored in different memory locations. I will soon tell what each data means. Thereafter, here is registers. So this memory is external memory. These registers are internal memory of microprocessor. All the instructions are stored in external memory. Now all the data is in hexadecimal. We know that one number of hexadecimal is equivalent to 4 bit. So when I am writing 2218, this will take how much space in memory? 2 bytes. And when I am writing 76, it will take 1 byte space in memory. Is this clear? Okay, so I have taken here, first we are discussing about 1 byte instruction. The instruction is add B. Let us suppose the operational code for add B is 76. B is a register inside the microprocessor. Okay, then add B means we are going to add data which is stored in register B 32 to the data that 32. So for the present case, now all the maximum mathematical operations taking part in 8085 happens with respect to register A. Okay, that's why register is different from other general purpose registers that are used in microprocessor. Okay, this was a part of your question as well in the quiz. So, and after the addition operation will be performed, the data will be again stored in register A. Okay, so in memory location 2218 we have written 76. So microprocess, whenever we are giving the instruction, program counter is pointing to 2218. Microprocessor will take the data 76. It knows that data 76 means we have a 1 byte instruction and the instruction is to add data of A and B. At this point there is no data or address with this instruction, so there will be 0 or there will be nothing in this place in the instruction format. Okay, after the instruction is executed, register A will have 64 because when 32 plus 32 are added, we get 64. I hope 1 byte instruction is clear to you. Then we have a 2 byte instruction. For the 2 byte instruction, I have taken an example of instruction MVI 34. This instruction means move immediately the data 34 into the accumulator. Okay, now 34 is a hexadecimal number, so it will be stored as 0111 for 3 and 0110 for 4. Therefore this whole 34 will take 1 byte. So OP code for the instruction is 80 suppose, and in data and address part it will be 34 which is stored. So if I have written the instruction at location 2219 80, so the next location will be 2220 which will store the data 34. Okay, in this way when I will be writing 80, whenever my processor will be fetching the data from this location, it will take 80. It will know that it is move immediate instruction. Program counter will increase by 1, and now processor will look for the data which is following 34. It is in memory location 2220. Okay, after this what will happen? We had 32 in our register A. Whatever is in register A is no use for us, and after the execution of instruction we will have this data 34 into our accumulator. Okay, as shown here. Now since 1 byte is for OP code and 1 byte is for data address, therefore this whole instruction MVI 34 is of 2 bytes. Next I am going to discuss a 3 byte instruction. 3 byte instruction will always have a 2-bit memory address like this is shown here. So in hexadecimal it will represent 2523. Memory address will be represented as this. Okay, 0010 for 2, then this should have been 5, sorry, this should be 2 and this should be 3. Okay, so this will take 2 byte in the memory. Okay, whenever there is 2 byte following, microprocessor knows it is an address. So PC was incremented. Last time we were in location 2220. Now the PC has been incremented and we are in location 2221. Suppose OP code for move A is 82. So microprocessor will know now that it has to look for an address that is to be followed. So address is written like this: 2523. This is the LSB and this is the MSB of the address. Microprocessor takes this data in. 82 is encountered, so it will look for 2 byte data which will be coming here. Thereafter it knows that it has to transfer from data from memory location this to A. Now this is the memory location 2523 which has data 65 stored in this. So this data will be moved to register A as shown here. Okay, with this data in register A was 34 which will now be changed to 65. So in these last 3 slides we have discussed what is the instruction format in a microprocessor, what type of instructions can be followed: 1 byte, 2 byte and 3 byte. Thereafter we have also seen data manipulation. Data manipulation instruction was add instruction, where 2 datas from register A and register B were added. We have seen 2 data transfer instructions, MVI and move. MVI is a 2 byte instruction, move is a 3 byte instruction. Okay, now bus architecture. Normally the different devices like CPU, memory, input output, whatever is connected to our CPU, whatever is connected to our computer system is connected by bus. Bus is a common pathway that connects two or more devices. It can transfer 1 bit of data. So if we have to transfer an 8 bit of data, we will need 8 bus, or we will have to send one data first, then wait, then second data, then wait, then third data, and so on. Okay. The main characteristic of the bus is that it is a shared transmission medium. This means multiple devices are connected to the bus and signals transmitted by one are received by all. So if a memory or a CPU is sending a signal, it will be received by all the devices which are connected on the same bus. Okay. Now if two or more people are sending data in the same bus, it will create problem. So there are particular protocols, that is set of rules, whenever we are sending data from bus. Okay. Therefore normally only one device can transmit at a time. Okay. Normally a bus consists of multiple connection pathways and each line represents binary 1 or 0. Thus 8-bit data bus is requires 8 bus lines. Bus connects major components of the computer such as processor, memory, input, output, and this type of bus is called system bus. Now in any bus architecture there are data lines, address lines, and control lines. Now we will see what is data lines, address lines, and control lines. Data line provides pathway for the movement of data between different modules. Address line is used to send address between different modules, and control line tells us which module can access the data at a particular time and which module cannot. We can take an example of WhatsApp group. Okay. In a WhatsApp group, everyone is allowed to send data. Okay. And everybody is sending from individual phones. So the IP address of the phone can work as an address line which tells who is sending the data. Whatever you are sending is sent by data lines. Now what is control line in a WhatsApp group? Then admin can decide who can send the message, who can read the message, or if no one can send the message. In this way you can understand difference between data line, address line, and control lines. Okay. Now there are different types of control lines in a microprocessor, like memory write, memory read, input output write, input output read, transfer acknowledgement, bus request, bus grant, interrupt request, interrupt acknowledgement, clock, and reset. Now finally bus operation, that is how a bus operates. Okay. So if a single module wants to send the data, then it must do two things. It will obtain the use of bus and transfer data via the bus. So first it will take the permission to send the data through a bus, and thereafter it will transfer the data through the bus. At this time no other module will be able to send data. The other is, if one module requests data from another module, then it should get access to the bus, that is obtain the use of the bus. Then it will request the other module to send the data. Then other module will get the request that particular module is asking for the data, and then the first module will wait till the data is sent by the second module. In this way a complete bus architecture works. Thank you. This is for your today's lecture. Soon you will get an assignment based on this lecture.